Hello and welcome to TidyX episode 70. All right, my name is Ellis Hughes and you can find me on Twitter at Ellis_Hughes.
And my name's Patrick Ward. You can find me on Twitter at OSPPatrick. And you can find the both of us via TidyX on Twitter at tidy_explained. You can shoot us an email at tidy.explained@gmail.com. You can like and subscribe on the YouTube channel, or you can open up an issue on our GitHub repo. And today we took a week off to kind of brainstorm a new topic series. We've I feel like the past several months rather, have been like topical, right? We've like covered something over the 3 or 4. We did some classification algorithms. We did some a whole bunch on data cleaning and dealing with regex expressions and things like that. Yep. So we took a week off to kind of brainstorm what was next. And one of the things that we came up with was, let's delve into using R to interact with databases.
Yeah. So this is something that I don't do a ton of, but I used to do it a little bit more, where I had to actually transition from R to actually learning how to do SQL queries.
And this is something that I do a ton of because it's something I have to do every single day. And actually, interestingly, if reading Twitter, as some jobs were being posted for the NBA, I think, and MLB, kind of like data analyst jobs, there were people saying on Twitter, like some really good R analysts saying, like, I don't understand these job descriptions. They all say like, analysis in R, blah, 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 but must be, must have SQL knowledge. And they're like, but I don't have SQL knowledge. And this is like, it's ridiculous. And it's like, oh, yeah, I can see why that's a problem. And I don't have great SQL knowledge. I know enough to write some queries. But today, what we can show you is a way to use all your R skills within SQL and also interact with the database administrator to be able to converse in a SQL language without having to explicitly know SQL. So this will make you super valuable.
Yeah. Meet them where they're at. You're on the same team, so there's no sense in fighting them and making them be frustrated with you. You're like, no, I just want it like as a CSV or something like that. Like, functionally, data can be too large to store reasonably in a CSV or too large in memory. So you really want to offload these. So that's why SQL databases exist. There's a lot of value in them. And so as an R programmer, knowing how to interact with databases and doing that work is really valuable and can really add, it's a really good tool to have in your toolbox.
Especially in sport right now with tracking data. It's very easy to work with one player for one practice for 60,000 some rows. So that, so then you think 90 players, right? And then it's like, so you're not putting that in CSV.
No. All right. So let's get going. Let me share the screen so Patrick can see what we're talking about, and then we will get going. All right, Patrick. So now you can see our screen. So let's do some basic setup so that we can get into the actual SQL work. So we have our packages that we're loading. So we've got tidyverse for our data manipulation needs. RVest is going to be doing some web scripting because we need to get some data into a database that we're going to be using. And then the star of today and probably the next several episodes, dbplyr, which is a very intelligent package built by some very smart people, which helps us converse our normal tidyverse world and deploy our syntax with our SQLite database or our SQL databases. And then we also have our SQLite and DBI, which are packages that help us do the connections and interact with the databases at a kind of lower level.
Yep.
All right, so we're going to pull some data. Patrick, do you want to kind of take us through that real quick?
Yeah, we can breeze over this. This is literally just to get us some data to dump into a MySQL or a SQLite database. This was actually, I think I yanked it from TidyX 1. So if you really want to hear the nitty gritty, basically we're going to read in an HTML from profootballreference.com. It's going to be the 2019 draft combine data. And we're just going to snag the table that's on that page, turn it into a data frame, and filter out the repeated rows of the headers. So every, whatever it is, 10 players, there's a new header. So we're just going to get rid of that. And that's going to pull us in a quick and a handy data frame that we can utilize for our database here. There we go. And we'll do a little quick cleaning here. So we'll kind of name some global positions. So for example, all the offensive line positions will be just called offensive line, the linebackers positions, linebackers, etc. So just a little bit of data cleaning. And then further on with the data cleaning here, that last kind of column that you saw when Ellis showed the data set is a bit messy. So we're just going to go ahead and parse it or separate it out into distinct columns of team, round, pick, year. And we're separating on that slash sign. And then we're doing a little case when here. So if the round is an A, that means the person was a free agent in that year's draft. They weren't drafted in an official round. Otherwise, we'll just parse out the number and we'll call it round, because I think it was like number 5 TH round 6. There you go. Yeah, 1 ST round. So just do that. And then for whatever reason, there's probably a good reason why we might have explained it in TidyX 1. I can't remember. The data all comes in as a character. So we just want to take all of those columns between body weight and the short shuttle, and we want to just convert them into a numeric. So now we have a nice database, a nice data frame that we can go ahead and conveniently load into a SQLite database.
Yep. Yeah.
Which we have to create We have to create the database.
We have to create to create the database in this situation here. Normally what you'd be doing is you'd be connecting to your organization's SQL database that exists somewhere on their intranet, or if you're using Amazon web services, it might be living there. But the point is, it's usually something that lives elsewhere. The places I've worked and the work that I've done has typically been a little bit more homegrown, which means we don't have those resources, at least what I've done. So there's a really cool package, RSQLite, which allows you to use SQLite. And SQLite is, it allows you to create databases as files on your computer. And so that's what we're doing here, just to, once again, really high level demo to show you how you might be able to do things, and so you could actually run it yourself. You don't need to have it living in, we don't have to have some S3 bucket or something running, or we don't have to have it living somewhere else, so you can do this as well. Right. And so this is from the dbi function. So you use dbconnect, which is saying, hey, I want to connect to a database. You give it the driver that you want to be using, and we're using SQLite in this case, so we use the RSQLite package, the SQLite driver, and then we specify the file or the location of the database. In this case, I want it to be stored within this episode's file folder, so I just give it the full path there and end it in a .db file extension. So I will run this code, and you will see down here in the lower right there, now I've got this file here that represents a database, and you can't actually open it up to look at it. Like, you can't just click on it because it's a binary file, but it lives in there. Okay, so
and it's empty right now, zero bytes. So
it's got nothing in there right now.
Load something in.
All right, so what we're going to do now is we're going to write our newly created combine data that lives here. We're going to write that into the database so that we can start interacting with it in the form of SQLite. So what we're going to do is we're going to code dbWriteTable, which is a function from once again dbi. We pass the connection. So this is unlike a lot of the way that you think about R objects, where they're kind of mutable and you overwrite things. This is now a connection. So this is like under the hood, when you're writing a lot of things to file and whatnot, you actually you just give a file path, like write CSV or something like that. It's actually a connection file, or a connection that gets created under the hood and then destroy it after you write it. Here we want it to persist because we want to continually be connecting to this database, connected to it. And so you just pass this dbcon object through the rest of our through the rest of this script. Actually, we'll be using this. Sorry, that's just a little bit of an aside. This is the name. So this is the name of the table that we will be creating in our SQLite database. And so the way that SQLite works is there's a lot of tables. So it's tabular structures of the data that exists. And so we're going to write that there, and then we're going to pass our data frame combine 2019 clean into it. So now we're going to write it. You saw a little pop there. It still doesn't show that there's been an update to the size here, but that's fine because it's kind of living in memory still. And now if you do db list tables, it shows we have this combine 2019. Here, I'll zoom in a little bit. Combine 2019 table that exists now, and I'm just going to disconnect from it. And so now you can see it actually wrote everything. It now exists in my combine.db file as a table, and you can skip this piece if you don't want to actually create a database file. If you were to clone or download this file now, you can just connect to it directly, and it'll have the combine 2019 data in it.
Yep.
All right, so that was a lot of words. Now we're going to actually to create the data so you can play with it. So thank you for sticking with us for 11 minutes while we get to the meat of the episode here. But we're now going to reconnect to it so now we can actually do our SQL queries and interact with it. And so normally the standard way that you might interact with the database is to have to actually write a SQL query. How does that work, Patrick?
Yeah, so usually this was kind of a cool week of preparation because I've never used the dbplyr package. This is normally how I would do my work, is I would actually connect to a database and I'd actually have to go into a SQL Server client, write the query that I want, figure out how I want the data returned, and then take that query and copy and paste it into this kind of db get query function in order to get my data into R. Basically get my RStudio to talk to the database to then run a SQL query from R and get the data returned. So this is normally how I would do it. So here we're going to create a query that returns this position counts data frame. So we use the db get query function. It does exactly what it sounds, db database get query. We make sure, again, as Ellis said, we're always going to be using that same connection because that's basically telling us we want to hit that database. And we write our SQL query in. So the SQL query, you could see, looks a bit funky for anybody who's never written SQL. So it's the most bizarre thing. Like when you write tidyverse, to me, it's very intuitive. You say, this is the data frame that I want. And then from that data frame, I want to select these columns and I want to group by this and I want to do these aggregations. SQL is like super backwards. It says, okay, first select all this stuff. Oh, but then do it from this data frame. And then, but group by this and then order by this. So to me, it makes no sense. And
then do this filtering.
And do this filter. Exactly. Yeah, the where clauses and all that stuff.
It's always backwards. Whenever I have to always relook at how it's structured so that I can pass it correctly. And SQL, by the way, stands for Structured Query Language.
Yeah.
So it's a standardized or vaguely standardized. Hey, this is how you send information and what you want to a database. And so that's why Google and those search engine queries are so cool, is they can take our normal language and convert it into some sort of query that it runs on their databases.
Yeah.
And it's also super fast, and it's got a bunch of other really cool stuff going on under the hood. But they're converting this into something that maybe looks a little bit like that. Yeah,
exactly. So it's a standardized language, but not standardized for my brain. But the way that this works is basically we wrote this query that said select the position group column and take that position group column, because we're only selecting one column, right? If Ellis did select star, he would be saying, I want every single column available in this data frame. In that data table, within the database. Here he's saying, I only want the position column. And then he puts a comma in and he says, and I want to count star. So basically I want to count the rows of that data frame. And I want to call it this new variable called n, which stands for sample size, right? The number of n. And I want to steal this data from the combine table within our data frame that we've dbcon connected to. And now my kind of filtering is I want to do this only where the school is equal to the University of Alabama. And then I want to group that position group. I want to group my count. So that's the count of rows by position group, right? So I want however many rows were offensive linemen, however many rows were running backs, etc. And then finally, I want to order this all by n in a descending fashion. So I want the highest number of the count of position group at the top, and I want the lowest number of the count of position group at the bottom. And if we run this, we're going to get a output that looks like something we could easily recognize and interpret. And we got it in a kind of messy way, but we can do this using dbplyr in our normal tidyverse language.
Yeah, so this required us to actually know SQLite, to know how to interact with it, know the order in which we needed to tell our SQLite client what to run. It took me a couple tries to actually write this query, so it did what I wanted it to do. So there were a couple times where it like, error, I didn't put something in the right order, or error, I didn't put quotes around the right thing, or...
Right.
Okay, but you can actually do this through dbplyr, and this is how you do it. So you take the function tbl, which stands for table. So which table do we want to be interacting with from our database? So tbl, the connection that we have to the database, and then the name of the table. That's pretty darn simple. So that replaced that piece there.
Yeah.
All right, now I want to keep only the cases, and this now you go into your like standard tidyverse syntax that you're super familiar with. Okay, what is the first thing if this was a data frame that you'd want to do? Well, first I want to filter to keep only the records that I actually care about, right? So you filter by school is Alabama, and that's where this is where that where comes from.
Yeah.
And then, well, now I want the counts of the position here. So you just do count position, which replaces a good chunk. It creates the select here and then the group by here, and then arrange descending n, and that replaces this order by n descend. Now when we run that, ba-doop, it now has run this query lazily because I've now asked it what that value is. It's now executed it. But in theory, this is now offloaded. If this was a big database or a big data frame, it might take a while to run. But it would hang up your computer. But more than likely, if your organization has a big database, it's probably got a pretty beefy server running it, it would look at this and laugh and go, yeah, no problem, I got this. Run it, bring it back to your computer. So this is a way to be able to use also the power of the server if you don't have a really powerful computer.
Right.
So now it's pulled this. There's a bunch of like information about extra stuff that exists that we don't really need to worry about here. But here's the data frame that we've got. And now we can start interacting with it as it was on our computer. Bada bing, bada boom.
Mm-hmm.
All right. So that's how we can do it. We can use collect. Collect will just convert it into a tibble, so it's local.
Yep.
But cool. But all right. So that's the cool thing.
This is the cool part.
But Patrick's really stoked about this piece here.
Okay, so this function, the show query function, I love because chances are if you work in an organization and you are an R analyst or R data scientist, and you have to deal with SQL databases to get your data, you probably work with a database administrator who doesn't know much R, might not know R at all. And the problem with those the R-based SQL query that we just ran above is that it can sometimes hang things up. It's not super efficient, especially if you're dealing with large data, especially if you're joining across a lot of tables. Table joins can be absolutely brutal in SQL, and they can really kind of slow things down in terms of how fast data gets returned. So if you took your tidyverse example and you went to your database administrator and you said, hey, I'm trying to get my data return and it's taking forever. This is what I'm trying to do. They're going to look at that and say, I don't understand what the heck this is.
This is a foreign language to me.
Yeah, exactly. But if you took that query that you wrote in Tidyverse and you piped in this show query function, you can now get returned, hey, this is what I'm trying to do in Tidyverse, and this is what it looks like in SQL query. And so now I can go down to the DBA and say, look, I wrote this query like this. Can you help me make this more efficient? And probably within a few minutes, those people who, I mean, there's some real SQL warriors, that can be like, they're like, oh, you're joining on this and this and this. That's going to be really long. That's row based. Like change it to this and it's going to be way better. And they'll write you a cool query, in which case you can scroll up to the part where we put the DB query in, and you can say, hey, my cool, super handy DBA wrote me a new SQL query. Now I'll just use DB get query and I'll paste it right in here between the quotes, and I get my data returned in a much faster way. And it's a super easy way to interact with the DBA where they don't have to learn a new language, and you kind of like don't necessarily have to learn a new language either. You just both get on with your work, and that's pretty sweet.
Yeah, you work together because they're on your team. They want to make you efficient. They don't want you hanging up their servers with inefficient SQL calls.
Yeah, that's
because it just makes things unhappy. And so this is really cool in that it converts all your code into a SQL query, but it's probably not going to be super efficient. Work with them. Go, hey, I'm trying to do this thing. I don't know how to write SQL, but this thing helps me do it. This is the query that it puts out to me. Help me. Help me help you help me.
Yeah. So
and
super cool.
All of a sudden you're creating synergy.
Yeah. That was really good. I love that. That's a super handy function. Mm-hmm. And then when we get to the end, we disconnect from our database.
Always make sure to disconnect from your database. Otherwise, there's just unnecessary connections just hanging up stuff. Yeah. And there we go. And this is like a very quick introductory of databases, interacting with them, the value of dbplyr, and what we can do with that, and how we can become best friends with our database admins.
DBAs, yeah.
All right, with that, we're going to call it. Thank you all for joining us for another episode of TidyX. My name is Ellis Hughes, and you can find me on Twitter at Ellis_Hughes.
And my name is Patrick Ward. You can find me on Twitter at OSPPatrick, and you can find the both of us on Twitter at Tidy_explained. You can hit us up on Gmail, tidy.explained@gmail.com. Feel free to like and subscribe on that YouTube channel. Post your questions, ideas, thoughts that you might have about dealing with databases and connecting to databases. We'll have a bunch more on this. And of course, if you don't like that, you can go to the GitHub repo and open up an issue.
All right, with that, thank you all so much. Keep on exploring your world. Bye-bye.